Let's talk about naming acids. We'll learn how to look at the chemical formula for an acid and write a name for it. This video is going to be an introduction to the topic, and then the next video is going to be a lot of example problems so you can really get some practice doing this. So if we're going to be talking about naming acids, let's start out by asking, what's an acid in the first place? Well, there are many ways to define acids, but for what we're going to be doing here, I will say that an acid is a compound in which one or more H+ ions are bonded or connected to a negative ion. Now, this isn't a perfect definition, but it's going to work really well for what we're doing here. So here I've got a list of some common acids, and we can break each one of these acids down into an H+ part and a negative ion part. Some of these negative ions are individual elements like F- or F2- here. Other ones of these negative ions are groups of elements that together have a charge. These are polyatomic ions like this one and this one. Now, just like in any ionic formula, the positive charge and the negative charge has to balance out. That means that the charge from the H+ equals the charge from whatever the negative ion is. So in this case, we have one H+ with a charge of 1+, balancing out one F-, which has a charge of 1-. They balance. In this case, the negative ion has a 2- charge, so we have to have two H+ to balance out the 2- charge from this. Now, why am I talking so much about ions if what we want to do is name acids? Well, it's for this really simple reason, and that is that when we're naming an acid, the name of an acid is based on the name of the negative ion that's part of that acid. So, when I look at the formula for an acid and I want to name it, I've got to separate it, just like I did here, into the H+ part and the negative ion part. I've got to figure out what this negative ion is. Then, I figure out what the name of the negative ion is. And then based on the name of that negative ion that I've figured out, I can then write the name for the acid. So let's talk about doing this with a few examples. There are really two types of acids. Ones that have oxygen, like these, and ones that don't have oxygen. There are different rules for how we name them, so let's start out doing some examples with acids that don't have oxygen. Our first example is HCl, definitely no oxygen here. So the first thing that I want to do is break this up into the two ions that it's made up of. Okay, one of these is obviously H+ because it's an acid, and the second ion is Cl-, right? I knew that it was going to be Cl, and it has to be 1- because the charge on H is 1+, and they have to balance each other out. Okay, so the negative ion that we're going to be working with here is Cl-. The first thing that I want to do is figure out what the name of this is. So here I've got this list. Cl-, we call this chloride. So in order to name this acid here, we're going to use these rules. If the negative ion on the acid ends in IDE, you take off the IDE and then you stick this name between hydro and ic. So this is chloride. We take off the IDE and we put chlor between hydro and ic. So we call this HCl, we call this hydrochloric acid. Let's do another. HBr, we're going to take this and break it up into the two ions it's made of. One of them is H+, because it's an acid, and the other is going to be Br, and it's going to be Br 1-. This is 1- because it's got to cancel out the 1+ charge that we get from the 1H+. Okay, so the negative ion that we're going to be working with here is Br-. We take a look at this chart. Br-, we call it bromide. So to name this acid that has bromide in it, we're going to follow these rules. We take the IDE off, we take the stem, BROM, and we stick it between hydro and ic. So we're going to get hydro, brom, ic, acid, hydrobromic acid. So that's how we name these acids without oxygen, where the negative ion ends in IDE. Now let's take a look at how we name acids that have oxygen in them. In acids with oxygen, The negative ions are polyatomic ions like these that have oxygen combined with other elements. And that group of elements together has a charge. These polyatomic ions end in ATE and ITE, ate and ite. And these endings are what we're going to be looking at when we name acids that contain these polyatomic ions. Now, it's really important to be able to recognize the polyatomic ions so you know what to call them when you run into them. I'm going to be using this chart in the video, but I recommend that you memorize a whole bunch of the polyatomic ions. Hopefully your teacher can suggest a list for you to learn so that you'll be able to do problems like these. As we move ahead, here's just a little review of what we did previously. So here's our first acid with oxygen that we're going to name, HNO3. We're going to break this up into the ions that make it up. One of those ions is going to be an H plus here, and the other one of the elements is going to be NO3, NO3 1 minus. It's everything else, and the negative charge here, the 1 minus, balances out the 1 plus on the hydrogen. Now, this NO3 is the negative ion that we're working with, so what's its name? It's a polyatomic ion, so I'm going to look at my list of polyatomic ions. This polyatomic ion is called nitrate. So that means that I'm going to be using this rule for naming the acid. If the negative ion ends in ATE, we take off the ATE and we add an IC. So I'm going to go from nitrate here to nitric acid. Ate to ic. Let's do another example. Here we have H2CO3. We're going to break this into the ions that make it up. Now there are two hydrogens here, so we're going to do 2 H plus. That's one part of it. And then the other part of it is everything else, so it's going to be CO3, and the charge on this is going to be 2 minus. It's got to be 2 minus to balance out the 2 plus charge that we get from the two hydrogens, okay? This is our negative ion, so we want to name it. It's a polyatomic ion, and CO3 2 minus is carbonate. I got that right here, so I don't have to write it in. Carbonate. So now using these rules, the name of the ion ends in ATE. So I'm going to take off that ATE. I'm going to replace it with IC. So I'm going to call this carbon, and then IC, carbonic acid. So that's how we name acids that contain ions that end in ATE. We take off the ATE from the negative ion name, and then we put ic and we add acid. Carbonate goes to carbonic acid. Nitrate goes to nitric acid. Now the other type of polyatomic ion ends in ITE. Let's look at how we name acids containing these. Here we have HNO2. We're going to break this apart into H plus, and then the polyatomic ion, which is everything else, NO2 with a 1 minus charge. NO2 1 minus, what's the name of it? It is nitrite. And the rules that we use to name these are that if it ends in ITE, you remove the ITE and then you put OUS acid. So we go from nitrite to nitrous acid. So nitrous acid is what we call the acid that contains nitrite as its negative ion. Here's one more example of how we do this naming with ITE. We have this acid here. We break it apart into H plus, and then everything else, which is going to be CrO2 with a 1 minus charge to balance out the 1 plus charge. The name of this negative ion here, CrO2 1 minus, is chromite, which means that the name of the acid that contains it is going to be chrome. I take off the ITE, I replace it with OUS, and then I add acid. So it has chromite in it. We call it chromous acid. So these are the rules for naming acids based on the name of the negative ion that's in that acid. How are you going to remember them? Here is a great mnemonic that I really like, okay? My ride has hydraulics. This isn't actually how we spell hydraulics, but you know, whatever. So IDE, hydroic, so that's how you name this type of acid. And then I ate something icky, because acids that contain ions with ATE at the end are named with IC, okay? And then finally, Sprite, ITE, is delicious, O-U-S. So remember these 3 sentences, you'll never ever have a problem with naming acids. I love this. It's great, particularly this with a ride that has hydraulics. It might be a Lamona GXL. I don't know. I want to talk about some important exceptions with naming acids. We learn these rules, but there are few acids that don't quite follow them. And they actually turn out to be very common acids. All right? So they are these 4 acids here that contain the negative ions phosphate, phosphite, sulfate, and sulfite. Okay, so if we took this acid and tried to name it using the rules that we've learned, we turn the ATE from phosphate into ic, and so we'd call it phosphic acid. That's actually not quite what it is. The name of this acid is actually phosphoric acid. You have to add this OR before the IC. I have no idea why it's like that, but I just want to let you know, because if you were being very logical about it and follow the rules that we've learned, you'd actually be wrong. So I just want to make sure that you know how to name this acid. And similarly, this here, which is phosphite, you might think that it should be phosphorus acid, but we do the same thing. We add this OR, so it's phosphorus acid. Okay. Now for sulfate down here, it's not sulfic acid, but we also add a little something here. It's sulfuric acid. We add the UR. And for this, which is sulfite, we call this sulfurous acid. So for phosphate, phosphite, we add OR. For sulfate, sulfite, we add the UR. These are the only acids that have names that are a little bit different from the ones that the rules would suggest. Just learn these. They still end in the right ending. It's just this little bit that we got to add in between the ending and the end of the element name. Now sometimes people get a little bit tripped up when they're naming acids that contain polyatomic ions that start with hypo or per, because these are a little bit different and they don't start right away with the element name. But naming acids that contain these ions is just the same as any other. All we want to do is look at the ending on these ions. So for example, this acid here that has permanganate, it ends in ATE, so that's the only thing you have to worry about. We change the ATE to an IC, and we call this permanganic acid. This acid here contains hypochlorite, but only pay attention to this ITE. We change it to an OUS, and we name this hypochlorous acid. So if you run into a hypo or a per polyatomic ion, don't worry about it. Just focus on the letters at the very end. So that's how we name acids. We take a look at the negative ion that they have in them, we look at the end of that negative ion, and then we use these rules to figure out what we should call the acid. Definitely learn this mnemonic so that you won't have to worry about naming. It'll just totally make sense because you will have memorized this stuff. And then finally, check out my next video, which is a lot of example problems, so you can get a lot of practice with this.